Okay, so let's do some labeling. So this has to be 24. This has to be 24. Okay. So this point here, this is like halfway between. This has to be 12. Okay. Okay. This is going to be 12. This is going to be 12. This is going to be 12. Okay. So this is, okay, so what do we know? This is the center point here. It's the midpoint. Yeah. Center of the circle. Okay, this is also center of the circle. We've also seen that this is equal to 12. So this is a radius. So the radius of each circle, is equal to 12. Okay, so what do we know? We know that we have 3 semicircles. So that's basically 1.5 times the area of. So let's just break it down into. It's 1.5 times the area of a circle, or we can see it a different way. We could see there's a rectangle. Okay, and then we're adding a whole circle. Okay, so we have 1/4 here, 1/4 here, and 1/4 here. So, okay. So this white part, let's do white. Okay, is equal to one circle plus 1 rectangle. So the area of the circle, that is equal to pi r squared. What's the radius of the smaller circles? This is 1, so it's 1 squared. The rectangle, this is going to be the length. So the length here is going to be 2. This radius is 1 times the width, which is 1. Okay. So this is going to equal 2. What's it out? This is going to be pi plus 2. Now we want the big semicircle. So this is the grey semicircle. Okay, so this is going to be pi times r squared, and then we are dividing it by 2 times 1/2. What's the radius? The radius is 2, it says here, so it'll be pi times 2 squared times 1/2. So pi times 2, so 2 pi. Okay, so let's put everything all together. So total area, the total shaded area, is equal to the grey semicircle, which is 2 pi, minus pi plus 2. So that will be pi minus 2. So our answer is B. Okay, so let's define the angles. So let's call this X, this is Y, this is Z. Okay, so let's find the area of this first sector. So this is going to be pi r squared. What's r? R is 1, so 1 squared, times the fraction. So you can do it as 360 minus x over 360. Then we have y So again, the area of the circle, which is pi times 1 squared. And then we have 360 minus y over 360. And then we have pi, the third sector, we have pi times 1 squared. And it will be 360 minus z over 360. Okay, so when we expand all this, we will have, we have 360 over 360. So we've got pi, okay, plus pi, plus pi, okay. And then we also have, we have pi over 360 times negative x, so I'm sticking negative outside, so this is going to be x plus y plus z. Okay, so 360 over 360, that's equal to 1. This part here is just going to be 3 pi. Okay, and we've got minus pi over 360. Do we know what x plus y plus z is equal to? These are the three corners of a triangle, three vertices of a triangle. So that's going to be 180. Okay. So when we simplify this, this is going to be 3 pi minus pi over 2, which can be written as 5 pi over 2. Okay, so let's give you a brief introduction to trigonometry. So here we have a right angle triangle. So this is my angle, call it theta. Okay. Then if we looked at opposite the angle, it's actually called the opposites. Okay. And then if we looked at the longest side of a right angle triangle, this is called the hypotenuse. Okay, and then the other side is the adjacent. Okay, so with trigonometry, there's three really important functions. First function is called sine theta. Okay, and this can be calculated by looking at the opposites over the hypotenuse. Okay, then another important function is cosine theta. This can be found by the adjacent over the hypotenuse. And then we have the third one, which you need to know, is tan theta. Okay, and this is opposite over adjacent. Okay, so these are three very important functions. And then the formulae. You can use an expression called SOHCAHTOA to help you remember. So SOHCAHTOA. So sine theta is equal to opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Okay, so here's some special triangles we can look at. This is the equilateral triangle. All the lengths are the same, so 2, 2, and 2. Okay, and also the angles the same, which is going to be 60. The sum of all angles is equal to 180. So let's explore this triangle. Okay, I'm going to put a nice little line down here. Okay, so this is going to be split. This is going to be 1, and this is going to be 1. So I'm going to draw my. We should be able to see that this is a right-angled triangle. So I'm going to redraw this. Okay, so here this is 2, this is 1, and this angle here is 60. This angle here is 90. So this angle here has to be 30. Okay. So we're going to use the trig functions to create some formulae. So what do we know? So we know that. Okay. So firstly, let's try and work out this side here. So we're going to use Pythagoras. So we have a squared plus b squared is equal to c squared. Okay. C squared. C is the hypotenuse. Okay. So let's call this A. We don't know what A is. So B is 1, so 1 squared. And then we have C, which is 2 squared. Okay. So let's just do the calculations. We've got A squared plus 1 is equal to 4. Okay. So when we rearrange this, we get A squared is equal to 3. Okay. Therefore, we can work out what A is. So A is equal to square root of 3. Okay. Now let's use our trig functions. So we have a sine angle. So this case is theta is equal to opposite over hypotenuse. Okay. Here we have sine theta is equal to 60. What's the opposite? Opposite is A. So here this is square root of 3 divided by the hypotenuse, which is 2. So when you are trying to calculate sine 60 in your calculator, okay, you don't need to use a calculator. You can actually write it, because usually a calculator is going to give you an approximation. You can write it in 100% accurate form, which is called exact form. This is square root of 3 over 2. Okay. Also, we can look at sine 30. So sine 30, this is equal to opposite over hypotenuse. Okay. What's the opposite? Opposite is 1. And we have the hypotenuse. Hypotenuse is the longest side, so it's 2. So when you type in sine 30 in your calculator, you can do a quicker way is using this special triangle. And so sine 30 is equal to a half. Okay. Have a go at trying to find tan 30, tan 60, and also cosine 30 and cosine 60. Okay, so let's go back to this triangle. Here, we've broken down to 2 right-angled triangles. Okay, so I'm just looking at 1 right-angled triangle. So this is 90. This angle here is 60. This has to be 30. So all 3 angles is equal to 180. This is 2. This is 1. For using Pythagoras, we saw that this is square root of 3. So you can show that. So square root of 3 squared plus 1 squared is equal to 2. Okay, just write it here so it's clear. So square root of 3 squared plus 1 squared is equal to 2 squared. Okay, so let's have a look at trying to find. Let's have a go at finding cosine 30. Okay, so cosine 30, this is adjacent over hypotenuse. Okay, so what is the adjacent? The adjacent is square root of 3. Okay, and we have the hypotenuse, which is 2. Then we can look at cosine 60. Okay, Okay, so cosine 60 is here, the adjacent, which is 1. Okay, and we have the hypotenuse, which is 2. Okay, and then we can also look at tan 30. Tan 30 is equal to our opposite over our adjacent, so opposite over our adjacent. What's the opposite? Opposite is 1, adjacent is square root of 3. Okay, and finally we can look at tan 60. So I should write it here, so tan 60. So that's equal to opposite over adjacent. What's the opposite? Opposite is square root of 3. Okay, and the adjacent is 1. And this simplifies to square root of 3. Okay, so let's look at another special triangle. This triangle is an isosceles triangle. We've got two sides which are the same, okay, and we've got two angles which are the same. So if we make these angles 45, this has to be 90 degrees, okay. So since we have a right angle triangle, we can use Socoterra, we use trigonometric functions, and let's have a little play with this. So let's have a look at sine 45. Okay, so this is equal to opposite over hypotenuse. Okay, so we have the opposite, which is 1. So we need to work out what the hypotenuse is. So we're going to use Pythagoras. So a squared plus b squared is equal to c squared. Okay, a is 1, so 1 squared. B is also 1 squared. Okay, and we can work out what c squared. So this is going to be 1 squared plus 1 squared is 2. So c squared is equal to 2. So c is the opposite to squaring, that is square rooting. So we have square root of 2. So here, opposite is 1, and then we have the square root of 2. So when you use your calculator, sine 45 will give you a very long, complicated number. It was only be an approximation, but if you want to write it 100% accurate, we call it exact form, you can write it as 1 over square root of 2. Also for cosine 45, this is equal to adjacent over hypotenuse. So this is going to be adjacent here. We use this angle here. Use the other one, doesn't matter. Okay, this is our adjacent. Adjacent is 1, and the hypotenuse is square root of 2. So interestingly, sine 45 is equal to cosine 45, and then we have tan 45, which is equal to our opposite over our adjacent. So what's the opposite? I'm going to use this angle here, but you may want to use the other one. It's 1, and the adjacent is 1. So 1 divided by 1 is 1. So tan 45 is just equal to 1. And you can check that with your calculator. Okay, so we're looking at ways of working out the area of a triangle. Okay, so area of a triangle is equal to half times base times perpendicular height. So area is equal to half times base times perpendicular height. Okay, so this height is really important. It has to be at an angle of 90 degrees to the base. Okay. Okay, So let's find ways of working out the perpendicular height. Okay, so I'm going to draw a nice little triangle here. So here this is my h value. Okay, and here this is a, this is hypotenuse. Okay, and I've got the angle C. Okay, so I'm looking for a trigonometric function that relates the opposite, which is h, with the hypotenuse, which is a. Okay, and that's going to be sine. So sine C is equal to opposite over hypotenuse. Okay, so what's the opposite? Opposite using these letters, this is h, and the hypotenuse is a. Okay, so I've got an expression for h here. So since we know that sine C is equal to h over a, therefore h is equal to a sine C. Okay, so I can rewrite this formula for the area of a triangle. It's equal to half times base times a sine C. You may also see another way of writing the area of a triangle. Okay, so here, rather than using the angle C, okay, you may want to use the angle big A. Okay, and here, in this case, the formula would be half times base, this is small c, sine big A. Okay, so there's just other ways using trigonometric functions in order to find the area of a triangle. Okay, so let's look at an example of finding the area of a triangle. Say, for example, that the base is 2, and this side here is 1, and we know this angle here is 60 degrees. Okay, so how do we find out the area of the triangle? So area is equal to half, okay, times base times perpendicular height. Okay, so perpendicular height. Okay, we want to find that. So what do we know? Let's just try and draw this triangle. So now this is 1, this is 60. And okay. So what else do we know? And this is h. So using a knowledge of trigonometry, so we have the opposite and the hypotenuse here. So sine 60, which is the angle, is equal to the opposite over the hypotenuse. What's the opposite here? Opposite here is written as h, okay, and the hypotenuse is 1. Okay, so we can say that h is equal to sine 60. Okay, so now let's put it all together. So it's half times the base, which is 2, times h, which is sine 60. Okay, and this simplifies to 2 divided by 2 is 1, and we've got sine 60. So we can leave it as that. If you remember from the triangles, okay, so special triangles, sine 60 is equal to square root of 3 over 2. Okay, so let's label parts of this triangle. It's this equilateral triangle. We know the radius of the circle is 1. So this is 1. This, I'm going to call it x, and I'm going to call this t. This bit here has to equal to x. This is 1. This is t. This angle here is 60. Okay. Also, we know what this is. This is equal to 2. Okay, since the radius is 1 for each circle, semicircle. Okay, so I'm going to create a nice little triangle. This is 2, this is x, and this is 1, t plus 1. And this is 60. Okay, using our knowledge of trigonometry, we've got tan 60 is equal to opposite over x, 2 over x. So, if you have knowledge of triangles, if this is 60, okay, we've got this is square root of 3, this is 1, this is 2. So tan 60 is opposite over adjacent. So this is going to be square root of 3 over 1, which is equal to 2 over x. Okay, so it's just going to be square root of 3 is equal to 2 over x. Okay, to rearrange that equation, we have x is equal to 2 over square root of 3. Okay, now we want to work out what's going to work out. We can work out what t plus 1 is. So here, if you know sine 60 is equal to 2 over t plus 1. Sine 60 is square root of 3 over 2. Is equal to 2 over t plus 1. So rearrange this, we get t plus 1, okay, is equal to 4 over square root of 3. Okay, now we have everything. Okay, so each side is x plus t plus 1. X is 2 over square root of 3. T plus 1 is 4 over square root of 3. This is equal to 6 over square root of 3. You multiply the top and the bottom by square root of 3. Okay, so square root of 3 times square root of 3 is equal to 3. So we have 6 square root of 3 over 3. 6 over 3 is 2, so this is equal to 2 square root of 3. Okay, so I'm going to break this into 3 parts. So one part is going to include a sector. And 2 triangles. Okay. And the second part will include another sector and also these 2 triangles. And another part will include a sector and 2 triangles. Okay, so let's look at just one part. So one part was the sector. This angle here is 60. And then we have the 2 triangles. So the area, one part, is the sector area plus 2 times the triangle. Okay, the sector area is going to be pi r squared. So r is 2, and the sector area, this angle here is 60 over 360. And then we've got the triangles. So let's draw this out. Here's one of the triangles. So here, the base is 2. This is going to be half the size. So this is going to be 30. 30, and okay, this is going to be 1. Area of triangle. Okay, is equal to half times the base. Base is 2, and the perpendicular height is 1 sine 30. This can be written as, since 2 divided by 2 is equal to 1, this can be written as sine 30. And sine 30 is equal to, what does sine 30 equal to? You know your triangles. This is 30. This is 1. This is square root of 3. And this is 2. Just because sine 30 is opposite over hypotenuse, which is 1 over 2. Okay. So we have the area of the triangle is 1 over 2. We've got 2 times 1 over 2. So this all simplifies to 1 over 6 times 4 pi plus 2 divided by 2 is 1. And since we've got 3 of these parts, okay, we have 3 of these parts, with the red part, the yellow part, and the green part. So we have to multiply it all by 3. So total is equal to 3 times 4 pi over 6 plus, okay, plus 1. Okay, so 3 times 4 is 12 pi over 6, that's going to be 2 pi. And 3 times 1 is 3. So the answer is A.